Hello students. Are you ready to dive into the exciting world of equations? Today we're going to explore both linear equations and quadratic equations. First, let's talk about equations. Think of an equation, let's say 2x squared plus 5x plus 6 equals 8. It's like a statement that says two things are equal. You'll see numbers and letters in equations, and those letters stand for unknown values that we need to figure out. Alright, let's start with linear equations in one variable. These equations only have one letter, like this. Ax plus b equals c. Here, a and b are numbers, and x is the letter or variable. For example, take the equation 3x minus 4 equals 10. The goal here is to find the value of x that makes this equation true. Here's an important note. When you move numbers from one side to the other, make sure to switch signs. If you're moving a plus across the equal sign, it becomes a minus, and the same goes for multiplication and division. Now, what if we have a linear equation with two variables? These look a little different, like this. Ax plus by equals c. For example, 3x plus 5y equals 12 is a linear equation with two unknowns x and y. These equations can have many solutions. When you graph them, they form a straight line. But sometimes we have a pair of linear equations in two variables. You might see something like this, a 1x plus b1y equals c1 and a 2x plus b2y equals c2. Now, the challenge is to find the values of x and y that work for both equations at the same time. You can even graph them, and depending on how the lines behave, you get different results. If the lines intersect, you have one unique solution. If the lines overlap completely, there are infinitely many solutions. And if they're parallel, well, then there's no solution at all. There are other algebraic methods to solve the equations. Like substitution, where you solve for one variable and then substitute it into the other equation. Or you can try elimination, which lets you add or subtract the equations to eliminate one variable and solve for the other. Alright, now understand the quadratic equations. These are super interesting because they involve squaring the variable. X squared plus bx plus c equals 0. Here's an example, 2x squared plus 3x plus 4 equals 0. Now, the solutions to quadratic equations are called roots. To figure out the nature of the roots, we look at something called the discriminant, which is d equals b squared minus 4ac. If d greater than 0, you get two real and different roots. If d equals 0, you get two real and equal roots. And if d less than 0, the roots are imaginary. There's also a cool connection between the roots and the coefficients of the quadratic equation. For example, if alpha and beta are the roots of the equation, the sum of the roots is minus b by a, and the product of the roots is c by a. If you already know the roots of a quadratic equation, you can work backwards to form the equation itself. For example, if the roots are 3 and 5, you can create the equation like this, x minus 3, x minus 5, equals 0, which expands to x squared minus 8x plus 15 equals 0. There are also special types of roots, like reciprocal roots, zero roots, and even infinite roots. It's like a whole new world of possibilities. So, today, we learned that equations, whether they're linear or quadratic, help us understand relationships between numbers. Now it's your turn. What's the main difference between a linear equation and a quadratic equation? Let me know in the comments. The complete curriculum for Class 10 is available on our channel. Check out all the links provided in the description below. Please make sure to like, share, and comment for more such videos.